These strings of letters and symbols had become one of the strongest tools for us to identify ourselves, especially in the online world of the internet. Of course, I'm talking about the usage of passwords, or sometimes people call it. Hopefully, I don't forget this word so that I don't have to press the forgot password button whenever I want to access my social media account, where I can argue that boneless chicken tastes better than bone-in chicken. Passwords are very useful in that we're the only one that knows it. Therefore, if you were able to input it in some sort of computer, the computer will know, hey, that's this person, so I will allow him to enter. That is to say, remembering sequences of characters and symbols in some sort had become one of the requirements for us to be online. But have you ever wondered, why does it has to be like that? Can't I just use my own face to determine who I am? Well, my answer to that would be, what are you? Only using your face to unlock your phone or something? Anyways, passwords have one key advantage, and that it is very simple for the user to remember and very hard for anyone else to crack your password. As long as you have a pretty good enough memory and you are the only one that has that memory, assuming you don't tell the whole world what it is, you can prove that you are that person. The part that says that a password is very hard for anyone else to crack is much more interesting though, because this is also the part where next we will go into the math behind what makes passwords so good. So hopefully you will stay tuned as I explain about an application of permutations in our daily lives to prove that a password is a tough seal to crack. My name is Muhammad Shah Azizi, and today I'll be teaching you about the fundamental principles of counting, specifically about permutation. I'll start by explaining what a permutation is. To put it simply, it is a mathematical technique that determines the number of possible arrangements in a set when the order of the arrangement matters. The key word here is order, because this might be confused with another thing called combination, where the order does not matter. Permutations are also commonly seen in the field of computer science, as they are especially useful for analyzing algorithms, and for our purpose of today's video, show why a 12-digit password is a higher magnitude way more secure than a 7-digit password. I have found that in some problem questions while researching for this video, I've seen a lot of people use the word combination and permutation interchangeably when talking about password. But from now on, to avoid confusion, I'll just use the word permutation, because I'm going to be talking about a password where the order of the character is very important and it does matter. So, to start our analysis, we should begin with something simple first. A one-letter password, which I know intuitively you know it's not even a possible password you can have, but we need to start somewhere. Note, for now, I want you to imagine these passwords are being used in a hypothetical primitive computer where it can only possess base 10 digits. So, in this example scenario, the only possible set of passwords we can have is only 10, and that is all the base 10 digits from 0 until 9. Now, let's improve our password a bit more and allow our computer to also accept letters. So now it has a total of 36 letters it can accept. Okay, now we can also allow the computer to distinguish between small and capital letters. I think we can do better. How about we should just include everything? Okay, now we have a total of 95 possible letters in the ASCII sets of characters that we can play with. Alright, now let's move on to trying to figure out what happened when we allow 2-letter password. How many possible permutations can now there be? In other words, Given 95 sets of characters, how many different ways can we arrange them, assuming that the repetition of characters is allowed? Before we can truly answer this question, we need to establish a few things first, and that is about the rule of product. This rule just states that when there are an A possible ways of doing something and B ways of doing another thing, then there are A times B ways of doing both actions. This is the main piece of our puzzle because now we know that our possible options of selecting our first letter is 95, and we will also have 95 for the second letter. Because we are allowed to repeat our option, using the rule of product, we can say that there are 95 times 95 possible permutations for a two-letter password. In addition to this, we can also generalize our equation by saying that an nth long password will have a 95 to the power of n possible permutations. Note, by the way, that if repetition is not allowed, the possible permutation would only be 95 times 94 because our second letter would only have 94 options instead of 95. Good. Now that we have derived this formula and understand how we stumble upon it, we can now go back to our example that we are trying to prove. What is the big difference in 12-letter password and our 7-letter password? As you can see, 12-letter password has 7.7 billion more different possible permutations than a 7-letter password. So that means a person with 12-letter password is 7.7 billion times more secure than a person with a 7-letter password. Obviously, a lot of things are simplified here and assume that password like this is more secure because of its length, but these cases are just minuscule compared to how much everything else is. The point that I'm trying to make and show is that making your password has a few more letters can leave a huge impact on how secure your password could be. And hey, of course all of this will mean nothing if you're not using a two-factor authentication for your password and keep forgetting what your password was altogether because of how long it is. Now, what I have right here is some example situation where we can apply the same math. So, for this example situation, let's say there were two hackers who is both trying to crack the same password. Hacker A manages to figure out that the password can only be 8 characters long, and Hacker B also knows this, but he also knows some additional clues about the password. Firstly, he knows that the password began with an unknown special character from 30 different possible options, followed by an underscore. After the underscore, it is followed by the word Jeff, but he is not sure what its case is. The last two letters, he knows for sure that they are not 13, 42, 69, or any number that have 0 in it. Through a method called brute force, where every possible permutation or combination is tested in order to crack the password, we learned that Hacker B cracked the password a lot faster than Hacker A. Can you state the difference between the possible permutation that Hacker A and Hacker B must check? Can you state why Hacker A is much slower than Hacker B? You can pause the video right now if you want to solve the answer for yourself, but in a few seconds I will tell you the answer and explain how we derive that conclusion. First, we need to figure out how many possible permutations can an 8 characters password can be. And from the earlier part of the video, we have learned that we can figure this out by using this formula. The answer for this should be 95 to the power of 8. But for hacker B, this is a bit different. Mainly because of the clues that were given. So there are 3 clues that were given to us, so we can figure it out one by one. We know that the first character should be a special character, and there are 33 different characters of them. And this is followed by an underscore where it can only be 1. So the answer should be 33 times 1 possible permutations for the first 2 characters. For the following 4 sets of characters, we know that you can only have the word Jeff in it, but it states here that it is not known what the case of the letter is, which means we don't know if it's a lowercase or a capital case. Since we know that there can only be 2 possible options, the answer should be 2 times 2 times 2 times 2 for the third until 6th character of this password. The last 2 characters are tricky, but all we need to know is that the possible numbers that we can have is 10 times 10, but we need to exclude all of these cases from the total. So for the 13, 42 and 69, there is 3 of them. And next, we also need to exclude these 3 cases, that is when the first digit has a 0 and the second digit has a 0, or the third case where both of the digits are 0. And the X that I put here symbolizes the number 1 through 9. So therefore, there is 9 times 1 possible permutations for these 2 cases. And all in all, the total value that these 3 cases added up into is actually 19. Now that we have figured out all the 3 different cases and clues that were given, all we need to do is apply the rule of product for all the 3 clues, and we will get the total permutations from the clues that were given for hacker B. As you can see, there is a difference between the number of possible permutations that hacker A and hacker B needs to check, and this is why hacker B is a lot faster than hacker A. I think the big lesson that we have learned from here is that do not ever give away clues about your password to anyone, because one day, without you knowing it, a hacker can just brute force their way into your valuable account. My name is Muhammad Shah Azizi bin Abdul Karim, and thank you for watching my video where I teach you about the math of permutation. See you later.